One-sided limits and limits involving infinity. We have previously discussed that in order for us to calculate for the limit of the function as x approaches c, we need to examine the behavior of the function as x approaches c from the left side and from the right side of c. Now, in this section, we will formally define one-sided limits. Now, the expression here is called the limit from the left, and we read this as the limit of f of x as x approaches c from the left, and it is equal to k. Now, this is the case if f of x is close to k whenever x is close to, but to the left of c on a real number line. Now, the expression here is called the limit from the right, and we read this as the limit of f of x as x approaches c from the right equal to k. Now, we write this expression here when we mean that f of x is close to k whenever x is close to but to the right of c on a real number line. Now, note that if you do not see a sign here or here, so there's no minus or plus in the limit statement, then we assume that the limit is a two-sided or unrestricted limit. To illustrate this, let us consider the graph here and find the following limits. First, we want to find the limit of the function as x approaches 4 from the left. So to do this, we will look at the behavior of the function as x approaches 4 from the left. So as x approaches 4 from the left, these are the values. And let's get the corresponding value of the function. Your function values would approach this value here, and that corresponds to 9. So therefore, we say that the limit of the function as x approaches 4 from the left is equal to 9. Next, we want to find the limit of the function as x approaches 4 from the right. So from the right, so it's the right side of 4. These are the values at the right of 4. So we'll look at the behavior of the function at these values of x, at the right side of 4. Notice that the function values is actually constant, and it is also equal to 9. So therefore, the limit of the function as x approaches 4 from the right is equal to 9. Next, let us consider the limit of the function as x approaches 2 from the right. So the positive sign here means from the right. Let's locate 2, and then these are the x values at the right side of 2. So the x's are coming from the right side of 2. Then you look at the behavior of the function as x approaches 2 from the right. You see that the function values approaches to 9. Next, let us evaluate the limit of the function as x approaches -4 from the left. So let's look at the behavior of the function as x approaches -4 from the left side of 4. So your x's are coming from this side here of -4, and then the particular y values or function value is this. So all the points will be mapped here, and that is y equals -3. So therefore, we say that the limit of the function f of x as x approaches -4 from the left is equal to -3. Now, compute for the limit of the function as x approaches -4 from the right. So negative 4 from the right, the x's are coming here. So for negative 4 from the right, the function values are here. So, and that corresponds to y equals 3. So therefore we say that the limit of the function as x approaches negative 4 from the right is equal to positive 3. Now let's take a look at the limit of the function as x approaches 1 from the right. So let's locate 1 here. 1, this is 1 from the right side of 1 is here. Those are the x values. And then you get the corresponding y values or the corresponding graph of f of x as x approaches 1 from the right. So as x approaches 1 from the right, your function values, or this is your graph, and that goes closer to this number here. And this one corresponds to 9. So that corresponds to y equals 9. So therefore the value of the function as x approaches 1 from the right is equal to 9. Now lastly, we want to find the function or the limit of the function as x approaches 2 from the left. So 2 from the left. So your x values will come from here and it goes to 2. So as x approaches 2, your function values approaches to 9. So therefore we say that the limit of the function f of x as x approaches 2 from the left is equal to 9. Now we say that the limit of the function exists if the left-hand limit and the right-hand limit exist and they are equal. And that is, we say that the limit of f of x as x approaches c is equal to L. This is true if and only if the limit of that function as x approaches c from the left is equal to the limit of the function as x approaches c from the right, and both of them are equal to L. To illustrate this, we consider the graph of the function f of x here and examine whether the limit of the function as x approaches negative 6 exists. So in order to do that, we will examine first whether the limit of the function as x approaches negative 6 from the left exists, and also evaluate the limit of the function as x approaches negative 6 from the right. Now, if both of these two functions exist and they both approach to the same value, then we say that the limit of this function also as x approaches negative 6 exists. Okay, so as x approaches negative 6, we look at these values here, and then we get the corresponding y value. Now our function would move here. So the function would move here and it goes closer to this point here, which is negative 1. So therefore we say that the left-hand limit is negative 1. Now the right-hand limit, the x's are coming from the right side of negative 6. And then you get the corresponding y value, the values of function f of x would go closer to this point here, or it would approach this point here, which is negative 1. So it's negative 1, it's here. So therefore we say that the right hand limit is negative 1. Now both the left hand and the right hand limit exist and they're both equal to negative 1. Therefore we say that the limit of the function as x approaches negative 6 is equal to negative 1. Next, let's look at the limit of the function as x approaches negative 2. So as x approaches negative 2, it's this value here. So let's look at the right-hand limit first. So as x approaches negative 2 from the right, x approaches negative 2 from the right, your function values approaches to this point here. And this point is equal to 2. So the right-hand limit is 2. Now, as x approaches 2 from negative 2 from the left, so as x approaches negative 2 from the left, the corresponding function or values, the corresponding y values of the function approaches 2. So it will just continue to increase without bound. We say that the left-hand limit, the function approaches to infinity, positive infinity, because the function increases without bound. So it will just continue to go or to increase up to infinity. So therefore we say that the left-hand limit is equal to infinity. Now this means that the left-hand limit does not exist. And since these two here are not equal, then we say that the limit of the function without the sign, that means you look at the left-hand limit and the right-hand limit and see whether the two are equal. Since they're not equal, then we say that the limit of the function as x approaches negative 2 does not exist. Next, let's evaluate the limit of the function as x approaches negative 1 from the right. So this is negative 1. We look at the behavior of the function at the right side of negative 1. So as x approaches negative 1 from the right, the values of your function will approach this point here, or that value, and that is y equals 1. So therefore we say that the right-hand limit is equal to 1. Now we look at the left-hand limit at negative 1. So the limit of the function as x approaches negative 1 from the left. So from the left of 1, x approaches from the left of negative 1. The function values approaches to 1 as well. So therefore the left-hand limit is equal to 1. So both the right-hand limit and the left-hand limit at x equals negative 1 is equal to 1, then we say that the limit of the function as x approaches negative 1 is equal to 1. Next, let's evaluate the limit of the function as x approaches 0 from the right. This is 0, x equals 0. So as x approaches 0 from the right, your function values approaches to this point here, which is 2. Similarly, if you get the limit of the function as x approaches 0 from the left, your function values approaches to this point here, which is also equal to 2. So since the right-hand limit and the left-hand limit are both equal to 2, then we say that the limit of the function as x approaches 0 is equal to 2. Now it's important to notice in this example that both of these limits exist because their left-hand and right-hand limits are equal. But at x equals negative 1, the function does not exist. And its limit still exists, and that's equal to 1. So when we're computing for the limit is the value for which the function is approaching to. And so therefore the function need not to be defined at that point for the limit of the function to exist at that point. Next, let's consider the given piecewise function here and determine the value of the limit of the function as x approaches 2 from the left. So 2 from the left, that means we look at this interval here and we locate where 2 from the left is located. So 2 from the left means x is less than 2. So to evaluate the limit here, we will just replace f of x by x squared plus 1. And then plug in 2 to x here. So this is equal to 2 squared plus 1, and that is equal to 5. Next, when we evaluate the limit of the function as x approaches 2 from the right, and the function is a piecewise function, then we will look at where we can find this interval in the definition. So x approaches 2 from the right side of 2. Right side of 2 means x is greater than 2. So therefore, we replace f of x here by the definition of the function at x greater than 2, which is x minus 1. So we have limit of x minus 1 as x approaches 2 from the right. And then to evaluate, we're just going to replace x here by 2. So we have 2 minus 1, and 2 minus 1 is 1. Now, to find the limit of the function as x approaches 2, you don't see a sign here, and also 2 is at the end point of the intervals. Therefore, it is important to look at the left-hand side and the right-hand side of 2, and it's already in here. So notice that the left-hand limit is 5 and the right-hand limit is 1. The two are not equal. So therefore, we say that the limit here does not exist because the left-hand limit is not equal to the right-hand limit. And also, if you want to get the value of the function at 2, note that there is no equality here. So that means the function is not defined at 2. So we say that the function does not exist at x equals 2. Now, in a case where there is an equality here, then you just have to know where you can find the equality. For instance, in the first one, then you use this expression here to obtain the value of the function at x equals 2. And if the equality is in here, then you would use this expression here to evaluate the value of the function at x equals 2.